So we're going to just do a problem here. This is in the notes, and I'll read it first. So we've got, it says train stations A and B are 350 kilometers away. Train leaves station A heading towards station B at 40 kilometers per hour. Let's call that VA. And then at the same time that a train leaves station A, another one leaves B heading towards A at 30 kilometers an hour. And the question is, where do the trains meet? Okay, so we'll call this VB. Now, one thing, there's kind of two ways we can approach this. Like, I already made a choice where there's two options. But what I did here is I wrote down VB as 30 kilometers an hour. And I'm going to leave it like that. But some people might prefer to say VB is minus 30 kilometers because it's moving to the left. So we need to take that, the fact that it's moving to the left, we need to take that into account, but I like just, what I'm doing is saying these are the speeds, just the magnitude of the, like how fast they're moving without regard to the direction. Yeah, when you just look at like how fast something's moving, that's speed, velocity takes direction into account. So we can say the velocity of B is minus 30 kilometers an hour. But I'm just writing down the magnitudes here. We'll take the direction into account later. Okay, so the question is, where do these trains meet? And let's start out by writing down the position of each train as a function of time. So let's start out, let's say that this is x equals 0. Let's say this is x equals d, where d is a distance between the two stations, which was 350 kilometers. Okay, so let's start out XA, the position of train A. Now x0, it starts at 0. Then we have the velocity of A times t, and there's no acceleration. It leaves the station going this speed, and it just keeps on going then. And so that's it. Now for train B, it starts out at x equals d. So this is the initial position equation. That's d. And now the next term, the initial velocity times t, well, it's moving to the left, so I'm going to write minus VB times t. And again, there's no acceleration, so that's it. Okay. So, yeah, the other option would have been to say plus VBT and put the minus sign there. But, it's the same thing either way. Now, we want to know where the trains meet. But, again, XA and XB, these are the positions of each train in this coordinate system. Like, if you plug in t equals 0, you get XA equals 0, XB equals D. That term's gone. So, like, train A is here, train B is here. And then as time increases, this number is going to increase, that number is going to decrease. Eventually, when they meet up, that's when these two numbers are going to be equal to each other. So when the trains meet, we have XA equals XB. And so let's plug this in. XA, we're going to solve when the trains meet first. So we can plug these in. XA is VAT. XB is D minus VBT. And now let's add VBT to the other side. So we have VAT plus VBT. We can factor T out. And we have VA plus VB times T equals D. And then T would be D over VA plus VB. So we have kind of two options here. We can solve for time or just leave it as it is as a variable and plug it in. Okay, so again, we can plug in the numbers and get an answer here. So we know how long it takes for these trains to meet. So now the question is, where are they going to meet? And we can solve that by plugging it into either of these equations. We should get the same answer either way. So let's do this way. Let's plug in XA. So that would be VA times T. And so what I'm going to do, I'll do it in two steps, just to be clear. Okay, so when the trains meet, that's where they'll be. Now, a question that students often ask in a situation like this, here we have our velocities in kilometers per hour and our distance in kilometers. Now, students often ask, do we want to convert this to the standard SI units? And I would say definitely not in this case. It'll be a lot easier if we don't do that. What I'm going to do, I'm going to actually rewrite this a little bit. Not that we need to, but... if we just rewrite it by just moving this term over here, we can see like this fraction, we have kilometers per hour divided by kilometers per hour. Those units are going to cancel out. So there's just no reason that we'd want to convert them. And then our final answer will be in the units that D is in, which is kilometers. So let's plug in the numbers now. We have VA, so we have 40, and again, we already saw that the units are going to cancel. And then VA plus VB is 70, and then times 350 kilometers. That'll be 4 over 7, and get rid of that common factor of 10. So what I'm getting is 200 kilometers. That's where the two trains meet. And so the question was, where are the two trains going to meet? And we just found the answer, so we're done. Except we're not really done. A very important final step is to ask if this answer makes sense. And we can a good way to do that is pretend we didn't solve it at all. What would we expect the answer to be? And so let's go back to the original problem and pretend we didn't do anything. We can come up with a range where the answer simply has to be. And let's assume that both trains were moving the same speed. Where would they meet in that case? Well, if they're moving the same speed, they've got to meet right in the middle, which would be 175 kilometers from each station. So if they're moving the same speed, they're going to meet here. But train A is moving faster, so train A is going to get to this point first. So they've got to meet up somewhere between 175 to 350 kilometers. We absolutely know our answer has to be in that range. And it is. So that's a good sign that we've done things right. If we got 150 kilometers, that's definitely wrong. There's no way this train is going to reach this point, before this train that's moving faster and would have to cover a shorter distance. And so now this is an absolute limit. Our answer must be in this range. Now if we got 310 kilometers, that's in the range, but that's nonsense. We know it couldn't be that, because there's no way this train is going to travel 310 kilometers in the time it takes for this one to travel 40. Their speeds are not that different, so we would expect our answer to be much closer to 175 kilometers. And again, it's very good to think about these when you actually solve a problem. Just ask yourself, does this answer make sense? And a lot of times you'll find, one simple mistake, you can get a totally ridiculous answer. And yeah, I've seen examples of that where, the answer, if the student just thought about it, that something definitely went wrong, and then you can fix it. But yeah, I think we'll stop here. I want to consider one more problem. That's a free fall, very important topic. So we will do that in a separate video.